The chart below shows an expression evaluated for 4 different values of x. Okay, there's x, and this is f of x, all right? And when x is 1, f of x, this x squared plus 7x plus 11 is going to equal 19. When x is 2, f of x is 29. When x is 5, f of x is 71. When x is 8, f of x is 131. Okay, so we're getting prime numbers every time we plug in a value of x, at least for these 4 values. And what we want to know, is this true for all values of x? Can we find anything for x such that f of x will not be prime? Okay, and what value of x serves as a counterexample? In other words, we're going to show that it's not prime. Okay, not always a prime number. And which one of these 4 is going to show that f of x is not prime? When x is 4, is f of x prime. When x is 7, is f of x prime. When x is 10, is f of x prime. And when x is 11, is f of x prime. Well, first of all, we have to discuss what is a prime number. Okay, what is a prime number? So let's list some prime numbers. The lowest prime number is 2. 3 is prime. 4 is what? It's not prime, is it? 5 is. 6 is not prime. 7 is prime. 8 is not prime. Now, most people, when I'm in a classroom and I'm teaching this and I say, how about 9? Is 9 prime? They'll say, oh yeah, 9's prime because look, 2, 3, 5, 7 are prime. But 9 turns out to be not prime. And that surprises students a little bit, okay? 10 is not prime, 11 is, 12 is not, 13 is prime, 14 is not prime, 15 is not prime, 16 is not prime, 17 is prime, 18 is not, 19 is, okay? So here are my prime numbers, and what I'm doing now is I'm going to list the factors of 4, okay? Because I'm going to let you kind of find out what is a prime number, okay? All right, what is a prime number? To kind of show you this, what a prime number is, we're going to list the factors of 4. 1 goes into 4, 2 goes into 4, and 4 goes into 4. The factors of 6, 1 goes into 6, 1 times 6 and 2 times 3 are 6. Okay? For 8, 1 times 8 and 2 times 4. Now what makes 9 not prime, it's very similar to these over here because you have 1 is prime, 1 is a factor and 9 is a factor, and 3 is also a factor. That 3 is what makes 9 not prime. Okay? Now for 10, 1 and 10 and 2 and 5. For 12, 1 and 12. 2 times what is 12? 2 times 6, and 3 times 4 is 12. So all these numbers go into 12 evenly. 14, 1 times 14, and 2 times what? 2 times what is 14? 2 times 7 is 14. 15, 1 and 15, and 3 and 5. And 16, 1 and 16, 2 times 8 and 4 times 4. 1 times 18, 2 times 9, 3 times 6. Okay, so these are all the factors of 18. Now the factors of 2 are just 1 and 2. Factors of 3 are 1 and 3. You see why these are prime? They look a little different than these, don't they? 5, 1 and 5, 7, 1 and 7, 1 and 11, 1 and 13, 1 and 17, and 1 and 19. You see why 9 is not prime now? Because of that 3, huh? Okay, now I have 2 other numbers I want to talk about. The number 1 is not prime. It has 1 factor, okay? And the number 0, well, 0 times 1, 0 times 2, 0 times 3, 0 times 4, 0 times 5, 0 times 6. So all these are factors, and it goes on forever, okay? So what makes a prime number prime? What do you notice about every one of these? You might say, well, and I've heard this definition before, A prime number can be divided by itself and 1. 19 can be divided by 19 and 1. Okay? Now, that's a pretty good definition, but what about the number 1? 1 is not prime, but 1 can be divided by itself, namely 1 and 1. So the fact that 1 is not prime kind of ruins that definition. By that definition, 1 should be prime, because 1 can be divided by itself and 1. So whenever they say a prime number is a number that can be divided by itself and 1, well, then they say, whoa, forget the number 1. So let's come up with a better definition of prime numbers. What is a prime number? Look at this. How many factors does 19 have? 1, 2. How many factors does 11 have? 1, 2. Count the numbers up here, the factors up here. Count them. 1, 2. 1, 2. 1, 2. All of these have exactly what? Two different factors. Exactly 2 different factors. So a prime number has exactly 2 different factors. 1 is not prime because it doesn't have 2 different factors. Okay? So here is a definition for prime number. Has exactly 2 different factors. Now just so you'll know about this, a natural number other than 1 that is not prime is called a composite number. Okay, let's go back to our chart back here. These over here are not prime, and they're not 1. If it's not prime and it's not 1 or 0, then it's composite. So 4, 6, 8, 9, 10, 12, 14, 15, 16, 18 are composed or composite numbers. They are composed of more than 2 factors. Okay? And you can find out exactly how many factors they have. All right? So a number that's not prime, other than 1 and 0, we call them composites. Composite numbers. Now here's a list of primes. How about that? Nice little list of primes. That's not all of them. Here's another list of primes. And that's not all of them, okay? That's about all I want to list, though. That's the list of prime numbers. Okay, we come back to our problem now. We want to substitute numbers, the numbers 4, 7, 10, and 11 into f of x and see if we can come up with a number that's not prime. So let's take x squared plus 7x plus 11, okay, and substitute 4 in there. That's the first number. So we're going to put 4 and we're going to put a 7 and a 10 and 11. Try all 4 of those numbers, and one of those is going to be a counterexample. It's going to give us a number. The f of x is not going to be prime. So plug in the 4 there and there. We're going to get 16. 4 squared is 16. 7 times 4 is 28. Plus 11. Okay. 16 and 28 is 44. Plus 11 is 55. Now 55 is not prime. So this is our answer. 4 is the counterexample. Gives us a number that's not prime. What about the other numbers? We want to know 7. Plug in 7 here and here. So we're going to get 49 for this one, another 49, and then an 11. 49 and 49 is 98, plus 11 is 109. That is prime. Okay? That is prime. So this is not the counterexample. 4 was the counterexample. This is not. 109 is a prime number. How about 10? 10 here and 10 here. That gives me 100. This is 7 times 10 is 70 plus 11. 170 plus 11, 181. That is a prime number. It was on our list of prime numbers, that big long list of numbers. It has exactly 2 factors. It can be only divided by itself in 1 if you want to use that definition to help us a little bit. Definition doesn't work all the time. Say it can be only divided by itself in 1. 2, 3, 4, 5, 6, 7, 8, 9, 10. None of those numbers go into that. All right? So this is prime. The last one we want to test out is the 11. 11 squared is 121. 7 times 11 is 77 plus the 11. Add these up. You're going to get 198 plus the 11. 209. 209 can't be divided by anything. Okay, it's other than 209 and 1. That's prime. Okay, so of my 4 answers, we have to pick A.